Welcome. So this is going to be a quick video to make sure I understand how Slouch Cam works since I'm making it, but sometimes the details get lost under the covers. And it's particularly going to talk about one optimization for face detection that we can make in Slouch Cam. So first off, just to show how it works, Slouch Cam basically detects your face and then tracks it live to tell you if you are slouching. So I'll lean forward, get a little warning, track it back. But the main problem is you can see I just pegged the CPU. It's working pretty hard to find my face in that video. So let's see if we can reduce that load and increase everybody's battery lives. So before I start, I want to say that all great work is done on the shoulders of giants. I'm actually using this tracking.js library, which has built-in face detection. I've forked it and modified it for my use case. And this is actually just a JavaScript port of OpenCV, which is the most popular open source computer vision library. So let's look at how we detect a face in a video. So I've set up a demo here. I'm just going to refresh it. And in this demo, you see we're scanning a lot of squares across an image. And this is basically how the computer tries to find your face in an image. It analyzes every single one of these squares and tries to determine if what's inside is a face or not. And it does it on several scales. So after it runs those small squares, it'll probably boost up the sizing and try to find bigger squares, but you can see my face is pretty big. It doesn't fit into any one of these squares. So all these would come back negative. Maybe if we double that again, we'll have more luck. Yeah, okay, now we're getting pretty close to the size of my face. I can almost fit into one of these squares. The problem now becomes that my face could actually fit into one of these, but because of my position, it's split across these four quadrants. So in fact, we can't just naively go one square without overlapping them. We need to do something more like this, where each square kind of overlaps, and it's hard to see. It just looks like a grid of small squares, but it's actually a big square, another big square. Each 16 small squares here is another one of those big squares. So let's see if we can fit my face into one of these. Yeah, probably somewhere around here. It would probably figure out that this is a face and detect it. So the optimization we can make here for Slouch Cam is we don't need to start very small every single time to find the face, right? Initially we do, because we don't know how the person is positioned, if their face is really close, maybe it's really far away. So just to be careful, we should start with a pretty small window, maybe something like this. But once we find the face and once we know its general size, like we did previously here, we kind of know the target size of my face. We don't have to keep scanning a small window again like this. I mean, Slouch Cam only cares if you lean forward to give you a warning. It doesn't really care if you back away from the camera. We're not interested in that. So once we've sort of calibrated the position of where we want to sit, we can basically assume that the face is going to be that size or larger for the duration of the program. And one interesting thing, actually, if we really run this with overlaps, this is actually how the current algorithm works. It does quite a lot of overlapping. So yeah, there you see it's streaming across. So it's doing a square window, basically moving over 2 pixels, doing the next one, and you can just see how many thousands of windows we're gonna have to run through here. So if we can just eliminate this, that's quite a bit of processing, because the smaller the window, the more windows will fit across the image. Compare that to a large window. Let's say 1/2 that size. That should move across a bit faster. There you go. So we'll probably finish much sooner with this size of window. So I think I'm going to code up this optimization here, and then we'll log back on our CPU load. So let's turn Slouch Cam on again. Move around, and we can see the CPU has been pegged. It's actually doing okay. But let's see if we can make this more responsive. It's a little bit laggy now. Let's see if we can improve that. Okay, so I went back and tried to optimize the code. Let's rerun the old code. Here we go. Okay, so it's tracking me now. And let's take a look at the CPU here. We're hitting 115. Still getting tracked. Still get the slouch warning. I get too close. See, we're pegging maybe 120 on the CPU. 120, 121.8. Now, let's look at the new version of the code. So this is the optimization that we put in. And here we go. Okay. So same code, still tracking me. If I were to go back really far, I wouldn't be able to find my face anymore, because we've set the window size to be this specific large area. Fortunately, I can't get far enough away from the computer to demonstrate that. But we can see the CPU here is now pegged more around 100. So we probably have a 10% improvement, 15% improvement in performance. It's pretty good, but I think we can make it better. And in the next video, I think we'll talk about the fact that we know where the face is in one frame, and in the next frame, there's no need to look up here for it, or down here, or over here, because your head only moves slightly in between frames. So instead of scanning across like we saw with the squares looking for the face, we can just limit the scanning area to the immediate vicinity of the face. Thanks for watching.